It's not simple intuitive. You have to build up the relativistic intuition. Please.
Sorry. Do we know what causes the time dilation? Like my... Pardon me? So...
There's a marvelous interview with Richard Feynman, who's a genius and incredibly clear ideas about all that, in which somebody asked them, if a magnetic force, a particle does that, do we know what causes that? What we know is that these things cause the rest. We don't know what causes these things. When Newton wrote his fabulous book, the Principia, he wrote a simple set of concepts, equations, ways of thinking. If you buy these, if you say, okay, let me think in this term, you can explain why things fall, why planets go around, why birds fly, how far a project, you can explain it. But now you explain all that in terms of this. And now you say, okay, what explains this? And Newton says at the end of the what causes gravity? And says this super famous sentence, hypothesis non fingo, in Latin, which is, I don't make stories about that. That doesn't mean that we cannot ask this question, right? Because now we know what causes Newtonian gravity, because we have another way of thinking, that space and times have this, the geometry of space is just measuring distances, right? And the thing we call measured distance determines the geometry, and that is affected by matter. So we have that way of thinking that explains why this ring, why, everything, including Newtonian. Now you're asking, what explains that? We don't know. Science is not about final explanations. I think if we think science is about final explanation, we get confused. Science is about finding a way of thinking with a set of basic concepts and basic relations, which express in equations, in terms of which we explain everything else. Now we can say, can we explain more? But I don't think there's a bottom line, a final, because whatever we do is explained in terms of something else.
Okay, thank you.
All right, we'll have time for the three in line. Go for it.
Hi. When is our trip going to start to hurt?
When is our trip going to start?
Hurting.
Oh, hurting. When it starts hurting. I thought we were asking about the ticket when we leave. Good question. Depends on the size of the black hole. So it's once we are in, it starts hurting when. Let me give a precise answer. If you're sufficiently small in the gravitational field, wherever you are, it's like gravity doesn't exist, because you're free fall, wherever you are. But if you're large, the different parts of you fall in different manners, so you're going push and pulled. So if you are a lake, you don't feel gravity. But if you're a big sea, you do tides, because gravity are different from one place to the other. So your head and your foot, we're inside this spaceship, we're going down slowly the black hole, and at some point, your head and your foot are too large for being small in the gravitational field, so your head is being pulled up with respect to your foot, and squeezed, okay? So the precise answer is when your size get comparable with the curvature of the interior. Okay? As long as you're very small compared to it's fine. But when your size is comparable to the curvature, then you... So for a small black hole, that happens immediately as you go down. For a very large black hole, you have to wait until this is shrunk around you. De facto, for a real black hole like that, is going to happen in few minutes after you're in.
Okay, thank you.
Hi, my name is Guillaume. Thanks to meet you, Doctor. I was just curious to know if it is possible to estimate the age of a black hole.
Oh, today, the existing ones?
Mm-hmm. The one we can see.
Marvelous question. Do I know the answer? Not from the black hole itself. That's a great question. In principle, in an empty universe, you go there and you see a black hole, certain size. Imagine you know that it was formed by a collapsed star. Can you know how old? No, you cannot. Mm-hmm. Now, of course, the universe is it's not just a black hole. We know what happened to galaxies. We know the cycle of when stars were. So we have an idea of how old they could be. But from the outside, young black holes and old black holes with the same mass are exactly the same. But if you go in, they're not exactly the same. And that's another thing, physicists get often confused. If you go in, suppose you have two black holes, same mass, but one is very young and one is very old. So the young one ends here. The old one has this very, very long tail. So if we could look at the inside, we would see the age. But from the outside, we don't see it.
All right. Thank you.
So one of the consequences of the quantum loop gravity theorem is this possible production of dark matter, right? But one of the things with dark matter is they're saying that's part of the reason why things like galaxies and stars would condense in the first place. So how are we going to form black holes without the presence of dark matter that's the result of the black holes?
Very nice. So you definitely should enroll in a research in cosmology. Yeah, that's one of the questions. Now, in what you said, we're talking about two different families of black hole. I said the black holes we see around us are a very different kind. Very roughly three kinds, even if there are intermediate ones. The ones that we know there are many, which are stars. They have to be a little bit bigger than the sun when they stop burning because all the hydrogen has been burned. The heat doesn't keep them up, and the weight squeezes them down, and they form a black hole. And these are black holes, the ones I said, a few kilometers. Then there's these huge ones, which typically are the center of galaxies. Most galaxies have a huge black hole in the center. There's a lot of research about that. I'm not sure I'm up to the last details about the research about that, but there's also confusion where they come from. Yeah. These are huge, and somehow the idea is that they formed and they grew, they kept eating stuff, but they're too big, and in fact, there's a sort of tension. How did they come out? Probably they were primordial, because otherwise they wouldn't have enough time to grow so big. But I don't think there is, there may be people expert more than me in this room, because I'm not an expert at that. I don't think there is clarity about the story about that. The black holes I'm talking about, we haven't seen them. Mm-hmm. There's a small one. So the remnants have to be produced by black holes that either were before the bounce, if the Big Bang was a bounce, or early in the universe, but small enough to have time to. So a possible scenario is that a lot of small black holes become remnants, form dark matter, and then this dark matter, as you say, that was your question, create the potential wells where somehow galaxies of black hole come.
So we're kind of looking more on those very small scale ones then that could possibly come close after the Big Bang. Awesome, thank you.
Thank you.
Wonderful. Final question from the audience.
Hello. I was just wondering, since you spoke about things entering the black hole and then it decaying and exiting as dark matter, I was wondering if it exiting as dark matter and that whole process could help us understand what dark matter is.
Yeah. So your question is, could this explain what dark matter is?
Yeah.
Yes, entirely. Let me be clear here. Dark matter, there's total evidence about it. So there's something out there, or some some whatever that create this phenomenon, which is dark matter, which is very well studied. And there are at least, I don't know, 6 or 7 explanations which are being studied. This is one of the possible hypotheses of what it is. There could even be a mixture of these ones. So we don't know. But if this story, again, I'm insisting, this is an hypothetical story. If this story is correct, that's exactly a possible explanation of dark matter. Maybe it could be a partial explanation of component dark matter. Maybe the story is sort of like that, but not exactly like that. But it would explain dark matter. And I like this explanation of dark matter. I sort of hinted that during my talk, but let me repeat. All the other explanations of dark matter that I know require to guess some new physics. Maybe it's not general relativity, it's relativity modified. Maybe there's a new particle. Maybe there is some supersymmetric particle. That was a preferred explanation some time ago. It searched, not found, so now it's out of fashion. Maybe there is some funny things totally different in the basic laws of physics. This possible explanation for dark matter, I like it. This is a personal opinion. I'm not sure it's a strong scientific argument, but to me, it sounds like a strong scientific argument. It wouldn't require any modification of the basic laws. Just quantum mechanics and general relativity, if we have understood how they work together. And maybe I can close with that. If we look what has happened, and I close to getting back to the beginning, if you look what has happened in the last decades, think about the Nobel Prize, gravitational waves, quantum mechanics and entanglement and all that, black holes, cosmology. I mean, all the Higgs, fabulous physics, fabulous steps ahead in understanding the world. Nothing new at all with respect to what was in the physics book 50 years ago, 40, 50 years ago. So 40, 50 years ago, after the standard model, quantum mechanics, general relativity, we had a basic set of laws that explain everything we see, including the new phenomena. It's just the great discovery about quantum mechanics. So look, the equation that was written down by Heisenberg is all right. Look, the equation that Einstein wrote down were right. All the other attempts, supersymmetry, high dimension, I mean, just change it. Nature said no, 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 no. So I think my colleagues have a lot of passion to try to invent something, some new theory. Maybe we don't need to invent a new theory. We have to understand the ones we have.
Wonderful. Okay. Thank you, Carlo.